Welcome to QFR 2.0, Quantitative Flow Ratio. This is the new version of the functional angiography solution of METIS, which means there's no need for a wire nor adenosine. QFR is based upon a 3D reconstruction from two angiographic images of the same coronary artery, acquired within at least 25 degrees difference in field of view. From the 3D reconstruction and the velocity specific for one patient and vessel, the functional significance at the end of the vessel can be calculated. Additionally, the QFR values along the entire analyzed vessel and the percentual pressure drops over all lesions in that vessel will be calculated. QFR has been designed to mimic the gold standard FFR as good as possible for intermediate lesions, so it has the same threshold value of 0.80. Many studies have been performed to validate QFR against FFR and for different types of patients and diseases, and more than 120 papers and abstracts have been published since 2014, and these studies include more than 10,000 patients and 14,000 vessels. Now let's have a look at the benefits of using QFR. For patients, physiological assessment without coronary injury. And it also means there's no adenosine needed, less or no discomfort and arrhythmia, faster functional assessment, which means a shorter procedure. For hospital administration, it means a reduction of pressure wires and adenosine, and also a reduction of unnecessary referrals from peripheral hospitals for FFR measurements. For cardiologists, this means a reduced procedural time, applicable in diagnostic cases and diagnostic labs, pre, during, and post-PCI applicable, and it's also applicable in all coronary vessels. Automatic co-registration of anatomical and functional data. The results are presented on a monitor in the cath lab, and no pressure wire preparation, normalization, signal drift, nor malfunction. We can confidently say that QFR fits very well in the clinical workflow. Once the two angiograms are retrieved, the QFR analysis can be done in less than 4 or 5 minutes by an analyst, while the interventionalist can decide to watch the analysis on the large display in the cath lab, or continue with the acquisition of other diagnostic angiograms while the analysis is being performed. When the diagnostic angiograms are made, the first QFR result will be shown on the display, and the interventionalist can interpret the data and decide how to proceed. It's important to note that the QFR analysis can be performed before a PCI, and in this case be used as input for the decision making, but it can also be used post-PCI, using 2 additional angiograms at the end of the procedure to create proof of the PCI success. To give you an impression how the QFR analysis can look like in clinical practice, we will show a real-time analysis. QFR can already be started before the first angiograms are acquired. The software will show the acquisition aid, suggesting angiographic views for the different coronary vessels. Once the first acquisition is made and received from the X-ray system, the QFR software will load this acquisition and show the acquisition guide for the second view. You can move the star in the rotation angulation graph to a location in the green circle segment for which the support line will be more or less perpendicular to the vessel of interest. After the second acquisition is made and received in the QFR software, it will be shown in the second viewport and the analysis can start. The first step is to confirm the use of nitroglycerin to prevent spasms in the vessel. Accept the series to be analyzed by pressing on the arrow below. In this workflow step, you need to select the ED phase, showing the vessel fully filled with contrast medium. If the ECG is not available, the ED phase needs to be selected visually. If the ECG is available, all ED phases are detected, and you can easily step to a previous or next ED phase. Next, you need to indicate the same anatomical landmark in both images. This landmark will correct for the potential movement of the heart due to breathing or small table movements. You will also need to indicate the start and end locations of the vessel part to be analyzed, preferably starting and ending at bifurcation locations. The software will automatically detect the same vessel part in the other view. Make sure the start and end points will be located at the same anatomical locations. In the next step, let's concentrate on the contours and correct them if needed. Once the contours are correct, the next step will show the 3D model, the automatically determined reference contours, and the reference diameter function. Check the height of the reference diameter function and the location of the reference contours with respect to the actual borders of the vessel. At the locations where the vessel seems to be most healthy, the red and yellow contours should be on top of each other. Now that we have all the anatomical information, we can get into the flow and QFR calculation steps. First, you need to choose the right QFR analysis model. This can be the left main LAD or other model. In this case, we are using the LAD. The first QFR value is shown. This is the fixed flow QFR based on the 3D analysis and the assumption of a fixed hyperemic flow. You can make the result more patient and vessel specific by using frame counting in one of the angiographic views. Indicate in which frame the contrast just arrives at the location of the endpoint of the analysis, and when it arrives at the start of the analyzed vessel part. Press on the next step to get the final result page. The Vessel QFR is the QFR value at the end of the analyzed vessel part. Next to that, you can select one of the lesions, and the corresponding parameters will be shown. In this case, the so-called delta QFR is 0.23, which means that there's a 23% pressure drop caused by this lesion. The residual QFR value is an indication of what the QFR value at the end of the vessel would be if this lesion would be treated 100% correct. You can also add a user-defined region of interest, which is by default the combination of the detected lesions. You can pick and move the index marker to check the QFR value along the entire analyzed vessel part. Once the analysis is finished, press on the Accept button, and the full screen analysis will close, and the review mode will show the final results in a window within the Metis Suite environment. The report is completely filled in, starting with a summary of the QFR data, the 3D reconstruction with a color coding of the QFR, some screenshots of the steps and diagrams, the anatomical and functional data of the analysis. The results can also be saved in a DICOM file and sent to PACS so that the results can be reviewed on any viewer in the PACS network. Save the results by pressing on the Save Session button. You can always open this session file later on for reviewing. So let's look at QFR in a nutshell. It only uses 2 angiograms. It fits nicely within the clinical workflow, and it can be calculated online pre, during, and post PCI. It can also help you decide which lesion to treat or not. QFR is a fast and patient-safe way to introduce physiology in your daily clinical practice. If you would like more info on what QFR can do for you, just have a look at our website, metis.nl, and give us a call. Alternatively, reach out to one of our representatives for your country. If you are using QFR and you would like to share your story with us, please let us know as well. We would be delighted to hear from you.